Hello everyone. Now we will be seeing the topic greedy knapsack. So as the name suggests, there are two parameters in it. One is greedy and the other one is knapsack. Greedy method means we are going to find two kinds of solution. They are feasible solution and optimal solution. Feasible solution is the one which is very good solutions for the given problem. So we can have alternative different forms of solutions, and in all those alternatives which is the best possible solutions that can be chosen, and that is called as the optimal solution. So this is the introduction of greedy method. So we are going to find a solution which is the best for the given question, and we have to find out for the given problem, which is knapsack. As the name suggests, it's a sack. That means it's a bag or a container where we are going to store all the items. So we have different parameters in it. Now we will check one problem so that you can understand it better. So we have four elements or four items that we are going to tell that as items or represent that as I. For every item there is a weight. That means when we put those items inside the knapsack, what is the weight that it is going to take up? That will be given by W. Next we have, once we put the item in the knapsack, the every item will be having one profit. The other alternate way of representing profit is value. So three parameters will be given in the question: the number of items that we have to use, the weight related to every item, and the profit of every item. So in the given question we have four items represented as 1, 2, 3 and 4. The corresponding weights are 2, 1, 3 and 2, and the corresponding profit is $20, $12, $10, $20 and $15. Finally, every problem has to tell you what is the maximum capacity of the knapsack. That means how much weight the knapsack can hold. So that will be given as W, or sometimes it is represented as M. Here in the problem, the maximum capacity of the knapsack is given as 5. Now we will do the preliminary calculations for the knapsack problem. So first we have to find out what is PI by WI. So profit by weight ratio has to be obtained for every item given in the question. So we will consider the first item, which will be represented as P1 by W1. Once we substitute the value, we'll be getting it as 12 divided by 2. Answer will be 6. Next we have P2 by W2, which is 10 by 1. Answer is 10. Next we have P3 by W3, that will be 20 by 3. Answer will be 6.67. Next we have P4 by W4, which will be 15 by 2. Answer is 7.5. So everyone has got this profit by weight ratios. Now this has to be arranged in increasing order. That means we have this weight of 10, which is greater than 7.5, greater than 6.67, greater than 6. Why we are doing this? Because we are solving greedy method knapsack. As told, in greedy method we have to get the highest profit. So according to the profit weight ratio, 10 is the highest value and 6 is the least value. Now we will find the corresponding profit and weights of these values from where we have obtained, that is 10 and 1. This is the profit, this is the weight. And for 7.5 we have obtained from 15 and 2, and 6.67 we have obtained from 20 and 3, and 6 we have obtained from 12 and 2. So this is the increasing order in which we have written, so that we will get the maximum ratio of profit by weight. Next we are going to solve using the main table. This is the heading of the table. First we have steps, the object which we are going to insert, what is its weight, what is its profit. Finally we are going to tell how much of the remaining weight we are going to consider, or this is called as the fraction. Fraction will tell us if we are going to insert the complete object or we are going to insert only the partial weight of that particular object. Finally, we are going to get the profit, which is the main agenda of the question, and this all will be done using the parameter called as RC. RC is called as remaining weight. If there is no weight or remaining weight, or there is no space in the knapsack, we cannot continue the problem. So we are going to stop the problem once the remaining weight reaches to the zero value. So first we are going to start with steps. In the initial steps, we are not going to put any object. So we have not considered any object, so there is no weight or profit, or we have no fractions. We have still not got the profit and the remaining weight, which tells the capacity of the knapsack, and that is given by M, and whose value is 5 in the given question. So this will be the initial step. Next we are going to put one particular object into the knapsack, and that will be the one which the highest profit by weight ratio, and that is got by 10, whose weight is 10 and profit is weight is 1, profit is 10, and the item will be 1. Okay, or the first object will be put in that. The weight is 1 and profit is 10. Now we have to put the whole item into the knapsack because there is lot of space in the knapsack. So we are going to tell that x is equal to 1. Okay, because x is equal to 1, because we are going to put the entire item into the knapsack, since this is the first value that we are going to consider. So what will be the profit? X into pi. X value is 1. What is the pi value? 10. So the profit will be 10. Remaining capacity will be RC minus. So RC, remaining weight is 5, minus weight. What is weight? 1 into x. X value is 1. So what is it? 4. 4 is the remaining capacity of the knapsack. So next we are going to move to step 2. We are going to insert the second item inside the knapsack, whose weight is, according to the profit weight ratio, the highest value is 7.5. So the weight of that particular object is 2 and profit is 15. So weight is only 2 and remaining weight here is 4. So we can insert the entire object inside the knapsack. So x will be equal to 1. So profit will be 1 into 15. Answer is 15, and remaining capacity will be 4 minus weight is 2 into 1. So this will be giving you the answer as 2. So remaining capacity is 2. Next we will move on to step 3. We are going to insert the third object into the knapsack. Okay, so according to the profit weight ratio, the highest value is 6.67, whose weight is 3 and profit is 20. But see here, remaining capacity is only 2, but the weight of that particular object is 3. So we cannot insert the entire item into the knapsack. So we are going to take only the partial weight of that particular item. That will be given as RC by WI. RC is 2, weight is 3. So answer of x is 0.6. Okay, so now we will consider the profit. Profit will be x into pi. So it is 0.6 into profit is 20. So answer will be 13.2. Next, remaining weight of that particular object, which is 0.6, and then we will get the profit as 0.6 into 20, whose value is 13.2. You can even get it as 13.3 if you consider this as 0.67. And finally we will tell that the remaining capacity will be equal to 0. We are going to tell that it will be 2 minus 2, that is equal to 0, because you are using only partial values of it and no more capacity is there in the knapsack. So once we reach this 0 value here, we are going going to tell that it is the end of the problem and no more elements can be inserted into this particular knapsack. Finally, we are going to conclude with the fractions. This fraction values will be x1, x2, x3, because you can see here that the objects only considered are 1, 2 and 3. We are not going to consider all the 4 objects which is given in the question. We are going to consider only 2 objects fully and third object in partial manner. So the value of the fraction is x1 is 1, x2 is 1 and x3 is 0.6. Next we have the profits for the given problem. The profit will be P1, P2 and P3. By seeing the profits in the table, we have got the values as 10, 15 and 13.2, and by adding all this we are going to get the total profit. So it will be 10 plus 15 plus 13.20. So this ends the knapsack greedy problem. Thank you.